Hello everybody, welcome to another stream. How we doing? Hey Captain Chica, how you doing? How you been? Oh, so last stream we were making some diagrams for the new devlog that I'll be making soon. So yeah, we're making like little diagrams like these basically. We've got like 3 now, um, or maybe a 4th. But yeah, so what I would like to do. Right, let's set it for there. Sorry. Um, right, I got the chat open here now. Just in time coffee. Oh yeah. See, I've got the ahead of time soft drink or fizzy. Today I got the tropical blast, 0 sugar free. Pineapple and grapefruit. It's one of those Vive drinks. It's pretty good. Oh. So yeah, this one shows off the microfacet thing. So we did this. It's made up of tons of little. We've got a debug drawing API, and this is just a bunch of boxes that have been rotated, and there's a box to hide the joint. So let's do something like that. Get the baby monitor over there, and right. So so what I want to do before we carry on with anything is I want to get the list that I made today, and I want to improve it. I basically just want to plan out the video and just think about all the diagrams that I want, what exactly needs to be in there, so we can just go and execute the plan. Because when you have a plan, things just become far easier. You don't have to stop and think. That happens a lot. So you only plan. Plan, then go. Right, so here's the old plan. Right. So we can extend it and everything. I guess we can dash this, so I don't have to number them. So microfacets. So we're obviously gonna have that controllable roughness thing. We've already got that. I probably need to show a sun and a camera, right? So sun and camera. I think they're all gonna have a sun and a camera, but more specifically, what is this gonna show? In this. Not using the Discord Electron client? Nah. Yeah, I don't like installing many applications. Like, yeah. Unless they're native, I guess. I don't think they had a client, actually. I never knew. How's it going, VMT? Good to see you. Have you seen the latest PBR? Right. With the power of Linux, we're back. So hey. Linux. Linux. Eh. Right, I'm gonna have to correct that when I next stream because it does that. But anyway. Hey Chandu, how you doing? Is that a big frequency? What is... Where was that? It was here, wasn't it? Oh yeah. Yeah, I got a Behringer sound card thingy-majig, doohickey. I got one of them. So the microphone hooks into that. But yeah, here's my lights and my balls. This is very plasticky spheres. That's them when they're sort of very reflective, and this is when they're when they're very smooth. This is when they're really rough, and then you can make them metal as well, looking. And then it's also got a bunch of debug modes as well. Like you've got the ambient color, the reflected contribution, Fresnel, light diffuse. So when it's metal, the diffuse light doesn't contribute at all. And then specular, and then all the different specular ones from there. Like the normal distribution, the geometry shadowing. Yeah, so it's all pretty cool. And you can change the light intensity, light color. There's been pretty decent. Yeah, there's no AA. I had to turn it off for some reason. I forgot why. But yeah, roughness of 0 messes up with makes the AA mess up as well. I got rid of the transparency rendering. Yeah. We'll do another version when we rewrite the ray tracer. But we'll obviously keep the shading though. No, I was doing the anti-aliasing in the ray tracer, so I just check how much the ray missed a sphere by, and if it missed it by a half a pixel, it would. Well, yeah, if it missed it by if it was in a range of a pixel, it will blur it basically, or it will make it transparent and then accumulate the color with the thing it hits behind. But yeah, I don't have that on at the moment, so. Yeah, I already had the fancy A8. Yeah, it's actually really good as well because it's kind of like it's precisely correct AA. There is a cost in the shader doing it that way, but it's more correct. Whereas if you do the post anti-aliasing, you get errors, and that's what all games typically just do. But yeah. Does it work well? Yeah, it worked. It worked quite well. I might have a screenshot. So I got a little screenshot viewer. No, a screenshot, and then I can view it in the game. But I can only view the previous screenshots, the ones that say it was texture 0, texture 1. But they're here. But yeah, like anti-alias is the. Don't know what that is, but yeah, this is when I'm a bit zoomed out though. But yeah, nice and soft. I think there's some graphical glitches though in some of these pictures. Anti-aliasing is on. But yeah, probably not too easy to tell the amount of spheres and how small they are. But they got AA basically. You can kind of tell here how there's not really a hard border around here. But yeah. What's the next step after PBR? I want to throw away my current render and redo it again. That's the next step. We're going back to probably a BVH based renderer. I've already got the code for it, but yeah. And I want to slightly change. And the reason is because when we do some form of like global, like the current way we're doing is we're binning it to screen tiles, so the acceleration structure is view dependent. And if you want to have different acceleration or you want to accelerate ray tracing from other places, you've got to essentially build another acceleration structure based on that perspective you're trying to shoot rays from. So I was hoping it would be massively faster, so compared to doing a BVH, but it didn't seem to be that much better. So I'm just going to go back to BVH, and that way I can shoot rays from anywhere, and they should be, and that they'll use the same acceleration structure, and they'll be reasonably okay. And I don't think I'm going to go with having spheres locked on a grid anymore. But we'll see. Yeah, we'll get more into that when I actually start the task and that. Is the ray tracing situation rays per? How's it rays per pixel? What? Oh, how is it performing rays per pixel? I don't know. I haven't really counted, but I think it for doing. How many spheres was it doing? Yeah, I don't know. It's hard to say. It's hard to say. I haven't got exact numbers. Yeah, it's not that much because I've already got it, and I can just improve on the implementation as well, make it more efficient. So I've already done a version of it, which is great. So yeah, it shouldn't be too bad to do the BVH version again. And then from there, I probably want to have a way to actually make objects, different objects, because so everything's still going to be made out of spheres, maybe. So just have a way of making models and stuff like that. So we'll probably come away from rendering for a bit and actually have a way to just create content. And then probably get back into rendering after we have some content, basically. What can be a small Vulkan graphics project? Don't start making an engine. I don't know. There is no small Vulkan project other than a triangle, I guess. So, regarding this thing, what do I want? So, I want to say, like, well, the sun, if you have like a sun that shines light and if there's a rough surface, the rays will bounce. So, maybe we can draw specific lines to here and sort of show, based on the surface normal, how they will reflect off based on the roughness. And I guess we can also, yeah. So, we can say hard code rays from sun against the surface and show how they reflect in different with different roughness. Right, so if my cable nudges, it does that. So hopefully I fixed it. Oh my days. It's funny how like people do that expecting expecting to get clicks, but I guess they get clicks because they wouldn't do it otherwise. It's strange. Yeah, I guess taking at least what VMC just said, you can just find a relatively simple game. You could just try and program directly that game. It could be Super Monkey Ball suggested there, or it could be more simpler like Brick Breaker or Tetris. you know, just find a reasonably arena-based game where it's literally inside one contained space, and then yeah, program directly for that game, I guess. And don't really care about making it general or anything like that. Right, so afterwards, after we've done like showing how you're basically showing about roughness, how roughness contributes to things looking different, or changing how light reacts and makes things look different. Then you want to probably show. See, I'm wondering when I want to introduce that you shoot a ray from the camera instead. Yeah, I think we'll do that right away. So after here, we'll say like, show that we sample, that we, uh, um, that we do lighting from the camera. Yeah. To show the lighting from the camera, so that's be a copy of the microfacets one, but just showing we do it the other way around with that sample area. Then we want to say what is diffuse. So that would be the stuff that bounces inside the surface and comes back out. So at this point, we won't have the rough surface anymore. We'll just be saying, yeah. Yeah, we'll say what's diffuse, what is specular. We can also go and show our debugging stuff here. We could say like, hey, we could show, oh, ambient is, yeah, oh yeah. Maybe. Yeah, what's diffuse, what is specular? I guess normal distribution, geometry shadowing, and for now. You probably then want to talk about, so I guess this is like specifically could talk about what is, this is talking about like specifically lighting with like light primitives, if you will, right? Ooh, yes, this is specifically lighting with light primitives, if you will. And then after that, you probably want to go into like, so what about the rest of the light, right? And we've already got those two diagrams done. It's the one where it calculates that diffuse irradiance map and the specular irradiance map. I think I'm going to actually change it to these names. They're called something different. It's called irradiance map and pre-filter map. But I don't like those names. Yeah, so I think these are all the diagrams that we want. And then I guess like, so what I got to figure out is like, where do I show code and how much code do I show in this devlog? That is the question. Like, so we go over to the actual code. You've got calculate surface color. Yeah, so I guess it's like how much of the details. Yeah, so I don't necessarily want to go too much into the details per se, because there's other videos that just do it better, which I will obviously link to. So yeah, I probably want to start off by linking. Okay. Start off by showing what we have. have done. Or showing PBR off. Showing the sort of references used. So I'll just go over those references. And then, yeah, so calculate surface color. This is the yeah, it's just the diffuser irradiance, specular irradiance, and then the radiance from the lights. So we right, that's another diagram I should show. There's probably one where what's that blog? Yeah, you probably want to show something like this, or basically all the different vectors that you're just going to be using. And what they are. So So metals will get covered in here as well. We want to say, like, you know, right, metals don't get the diffused light, or don't. Right, it's coming back now, isn't it? Or is that coming through the webcam? Oh no, good. I don't know if it's my USB port or something else. Like the USB hub thing that I'm using, it's just dangling, it's probably wrecked. Yeah, notes for a devlog basically. I'm just figuring out what diagrams I want and how I want to do the whole thing. But yeah, we'll get back to doing some diagrams when I just figured it all out. Because yeah, basically my devlogs come from just like cutting down the stream. But this one's been different because I was like, I want to actually put a little bit more effort into this one because it's kind of important. More important that it makes more sense rather than me trying to understand PBR and then over about 5 different devlogs. So yeah. So where do I show code here? Oh yeah, no, I need to show that diagram. Ah, All in the Mage. Thank you so much for the second sub there. Appreciate it. How you been? Right, let's put the word diagram beforehand. Right, so this other one is like a diagram, right? Showing all the vectors, right? show all the different vectors used in PBR. What is diffuse? Show metals don't get diffuse light. So are we showing, like, where are we showing code, if you will? So I guess we're gonna, yeah, this is basically about talking about lighting a surface. Lighting with lights. So we'll probably end up showing, see, yeah, so I could probably at this point show the code without the reflected or diffused light, maybe. Well, I have my different viewing modes. Show code for the diffuse, which would be this one here. And show debug view. And then I guess over the specular. And then show how it's broken down into those three. I guess I'll just put that there. And then, yeah, okay. I think that makes a good video. Cool. So going back to what we need to, what diagrams we need to do. Delete all that. So, showing PBR off. Right, okay, diagrams. Microfacet, we need to hardcode some rays. So let's see our current diagram. It's got the microfacet here. This is showing how big the pixel is. So the first one just needs to show so the pixel doesn't have to be shown. That's actually probably the second diagram. So I guess let's copy paste it. Where's that switch statement? Oh, it's here. So the first one sweet. The first one is going to have a microfacet raised against the floor and how they reflect with different roughness. Sweet. So we need a sun. So let's get a sun or something. So this camera position, we are just going to rename that to sun. And we move it to the left hand side, so negative, that's 6. And the ray is going from the sun towards the pixel, and also what's the camera? Yes, the camera then will need to be like, sorry, the sun, yellow. Right, so we take a look at that, see the change. So it's from the left hand side now, here's the sun. Obviously I've got to change these about, right? Give these a, yeah, maybe I can move them in a bit, because they're a bit far away from the graph. But yeah, so we need to get rid of this pixel thing in the surface normal probably. So let's get rid of that pixel thing. That will come back in the next diagram. So where are the rays going? There's going to be a few different rays. So I guess I can just say we're going to have different hit positions. Hit 0, and you have a ray We draw an array. And then there'll be a reflect after that, wouldn't it? Yeah, so I guess if we just say you have like 3 hits, and we'll hard code those in, we'll figure those out. Then you're probably gonna have 3 rays. No ray direction anymore. Right, so we could probably just do a for loop over all those different rays. So hit pause, index, and then we need to do a reflect after that, but let's just see it working. Yes, declare these properly. So I don't really know the exact positions. What is that? Oh, that's the pixel. Oh, that's the surface normal. Okay, get rid of that as well. Yeah, so we need to figure out the positions where we need to go to. So let's just say -1, 0, and 1. And we'll tweak their positions accordingly. Right, so there's the 3 rays coming from the sun. So what's interesting is they're kind of going a bit behind. It's because they've got a 1 there, so let's make that 0 on the Z. Hey man, what am I doing? Hey Timo. So I'm currently making some diagrams because I want to go over and explain PBR in a devlog. So I'm kind of like giving like a kind of visual. So we've done PBR the past few streams. So we've got working quite well. We're just kind of recapping like what goes on in a PBR renderer. And I'm going to put it into a devlog so it's all nice and easy for people to consume and give a bit of a different perspective to PBR. I guess more of like a programmer perspective rather than just into the theory, probably. But yeah, how's it going? So yeah, so I'm just making these nice little diagrams. We've got it all planned out. Just got to get some diagrams written out. So I'm drawing all these surfaces here. So we're just using the debug drawing API to quickly get some diagrams done, and the code just gets thrown away at the end of it. So yeah. So it's going to be ugly, it's going to be a bit cryptic, but it's going to do the job. So these are the slabs, right? The slabs start. I'm a bit confused. Oh, the sun's at -5. Right, that's why. There we go, those arrows look better. So when you increase roughness, it goes more like that, right? So what we want to do is these rays have got to sit on different parts. And so I guess this one can go here, and we'll watch it reflect. Now, the problem is it goes there, it can reflect into there, then back there, which this case isn't handled by PBR from what I've understood, where it bounces off, bounces out, and bounces into the camera. That is not handled by PBR in the statistics that represent this microfacet thing. But yeah, so you don't. So we definitely want one about here, so it can reflect off. bit funny. That's obviously super rough though. One little back. So we'll move this one back by 0.1. This one probably back by 0.1 as well. And then that one can go forward. But yeah, let's change it by 0.1. So hip positions, 0.1, minus 0.1, then 0.1. So let's try that. All right. Yeah. So clearly that's fine. This one needs to go back. These need to go back a bit. And then I probably need to get it to maybe elevate a bit as well with the roughness, because that's just a little bit. So this one never seems like it's moving to me, but it is. Right, it's probably in a good position. Somewhere like there. I can just reflect out like that or something. This one, just go back by another. Something like that ought to be good enough. So I guess we can maybe change the elevation of some of the, like these based on the roughness. So that's sort of like y-axis. We can just say, hey, this is equal to like material roughness. Maybe 0.5, I don't know. Divide by 0.5. Divide by 2. I don't know. Yes. We want that. Write that out. Okay, clearly not good enough, but it's getting close, right? Right. So we probably want to actually start it off at like the negative 0.2. And then we probably want to like change this to like 0.4. And that should get it sort of just good enough. On the floor. Right, so clearly the scaling is a little bit off still, so 3. Right, so they look like they're touching, already touching. So yeah, so still a little bit more down. 2, maybe 2.5. But we'll see. Right, it's quite good. I can still go down a little bit, so maybe 1.5 or 1.5. That's what I meant to say. Let's kill all those games. Righty-o, so that is looking good. So the next thing to do is get some kind of surface normal so we can reflect these rays nicely. So the reflection Um, uh, so the normal, so it's just Y and then it's just rotated. So the first one's one. Yeah, this one is a negative rotation, positive rotation. That one can probably just make do with a different kind of one. We could just say that just gets bounces off like that or something. So we're probably better off hard coding them just so they look kind of good. So I guess we'll have a bunch of like normals. So with these normals, we do have that transform which is here. So if we move that up here, what we can do is say, okay, the first one is going to get like a mole. Wait. Yeah, so we're going to take an up vector. So v, I want to take an up vector 0, 1, 0, and I want to multiply that with r1 because that's the one with the negative rotation. Then this one wants the positive rotation, and then the third one we just wanted it to just keep. Well, it could probably have, let's just give it the up vector. Let's just say it doesn't change. Let's just say it's got the well, it is gonna, I might need that one. Yeah, the same one, I think. Right, so this one needs so now basically you want to draw the reflected ray. So this gets you your vector. So you just call it vec. Wait. That sub that. I guess you then want to say reflect. This. So you probably want to take, what do you want to call this? Let's call it vec, I guess. So it's a vector from the sun to the hit position. Then we would like to say reflect that vector via the hit norm with the hit normal, and just see what happens there. Obviously it's got to go from the hit position as the starting point for this vector. Hey Dora, how's it going? Good to see you. How you been? I put my parameters the wrong way around. No. All good. Awesome. Good to hear. Oh, Friday tomorrow. The end of the week is nigh. Right, we're getting some reflected rays. Nice. That one looks a bit weird though, not gonna lie. So I think the vector's just really wrong. We need to draw the normals. Let's draw them red. We want to draw them from hit pause, normal, probably scaled by 5 or whatever. Make him a nice red. Yeah, line's all good, my friend. Line's all good. It is complete. We're just trying to figure out. We're just trying to make some pretty little diagrams to explain things to people. Right, they went the wrong way around. Those rotations are the wrong way around. What's the squiggle? It's showing roughness in a surface. Yeah, that key on the right is wrong. Damn it, they are just gonna go into the floor, aren't they? That ain't good. What do we want to do? Um, I forgot it draws a 0.9, didn't it? I messed it up a bit. The drawing multiplied it by 0.9. So it messed up my vectors on how they are positioned. So their y's and x's are a little bit off. No. Right, so that means they need to actually be brought to the left a bit more. And okay, right. Let's do that again. So then the floor again. But yeah, so basically we want ours. Mm. Mm. Yeah. I guess we can show. We'll do smaller reflected vectors. So we'll show how they. Yeah. We'll do smaller ones, I think. So we can have them in. So let's just elevate them up a bit and just see where they are. So that will just be the rough. Let's take away this -2. That should be enough. No. Just a little bit of a +1. +1.5, I guess. Right, they're kind of above the surface. Yeah, on the surface there. All right. So if we, that'll go back by about a 1. That'll go back by about a 2. That'll go back by about 3. So 1, 3 back though, yeah. Then back by about a 3, a 2. That was it. Oh. No. Right, that one's fine. I need to move that one. And then back. 0.8. Let's try that. Then we can add those vectors back in, those hip normals back in. Right, that'll be alright. Yeah, let's move that back by 1 more. Right, so I think that's okay. So with these normals now. Oh wait, I just realized. That'll be 10. be 1, wouldn't it? Because it's negative, but the increment and decrement in Vim wasn't catching the sign, so that's why it felt like it's confusing my brain. Right, there we go. All right, that'll do. So we're drawing the reflected vectors now. So this one would be, so the normals are, let's make sure the normals are okay. So the normals of the surfaces they hit, they're not the normals. I guess I could just look to the reflective rays, to be honest. Anyway. Yeah, the normals are what I want there. That's good. So then, let's get rid of that. So let's make these, let's give this a very sort of small, well, let's scale this vector down a bit, I think. Do like a 0.4, just make it a bit smaller. Probably should go a bit less, to be fair. There we go. There should be a different color, obviously. There we go. So they sort of go into the ground again. Not good. But yeah, it goes to show, and then it goes, yeah. So we can make them just a little bit smaller. Oh, little, way smaller, 0.1 times that. And then I probably want to give them a different color. So we could say, hey, these ones are, we have a good selection now. But I guess I could get the surface of the, as reflected light. Give them a green color, I don't know. Let's give them a completely different color because it's a bit confusing. Let's give them an orange or something. Violet. Rightio. Okay. Maybe an orange. So I'm thinking we should move everything a little bit closer. Where's that floor? Yeah, here we go. So that should just make it a bit bigger. Just made it a little bigger. Maybe -6. Make that just a little bit bigger. And there we go, should be fine. Guess you're kind of seeing the glitches now, or the artifacts now, or the... That doesn't necessarily matter. It's alright. So, yeah, so we're just describing this thing called like a microfacet. It describes the surface. No surface is really perfectly flat. Well, I guess, and then like, you know, as The rougher the surface is, the more the light reflects. The more the lights are no longer like a perfect reflect. They can kind of let bounce. Yeah, they bounce different angles and it will create like a blurrier image. So that size of that thing was like, try to make it a bit bigger. Right, I think those vectors are a bit better in size. Technically they would reflect again, but yeah, I can just say. Or maybe I can stop it. I can stop it. And say that's the maximum roughness. Maybe the way we're scaling it is just incredibly wrong. Or is not helpful. So 0.5 we could times by 0. Wait. So did I go the right way there? Obviously the wrong way there, so 2.5. It's perfectly flat when it's a little bit rough, and then it just get blurrier and blurrier. And we'll just leave it at that. So we want to say this is the surface. So where's the UI? So the teal is the surface. There's no pixel anymore. There is a reflected light. So that is, what was that, like an orange? Oh, it was the sun. Sun was yellow, wasn't it? So yellow is the sun. Then there's also like yellow rays as well. Were they yellow rays? I think they were. The line. And that'll be the lights. And you have reflected light. Right, that's pretty sweet. So I think that's that diagram done now. So you got the sun, light, reflected light, surface. Boom. Cool. So the next diagram is, we want to show that we do lighting from the camera instead. So basically it's a copy of the diagram we've just done, but it has that pixel thing as well. So what I would like to actually do is copy this back. Yeah, so we'll copy this over to here, but I want to make sure that we so that pixel, and we also need the camera as well, and that ray. Yeah. So what we're showing in this next diagram is we don't shoot rays from the sun. We should shoot from the other way around. So that will be over here. Nice. Then we need the pixel. So we're not drawing all of those rays again, we're just drawing these rays. So it'd be something like that. Where's the sun? I need the sun back there. Right, let's see how that works. Yeah, it's got to delete the rest of this. Step position. Oh, did I delete step pulse? Ah, shoot, why is that on negative whatever, innit? Yeah, -6. Alright, so we want to move over to diagram 2. Diagram 2. Right, so this diagram is showing that, hey, there's this like sample. So we still have this thing, maybe we'll get rid of that. But yeah, you have a pixel here that we're sampling. Yeah, okay, we're getting rid of that. No, I think we'll keep it. Yeah, we'll keep it. So there's a pixel that you're sampling. You shoot away from the camera instead. What's going on with that? Is that? Yeah, so that's pointing back. So we need to correct. So just think of the -6 did they? So the pixel position, -6. I think that's it. Right. Actually, I just realized. Yeah, we need to draw the actual pixel thing. Where is it? It's this one. No, it's not it. It is this one here. So we need to actually subtract here just the y component, probably by about a 1, or maybe more. Oh no, not the y, sorry, the z. Whoopsie. Dun dun dun. Right, I went to subtract, I went to do an add. So that puts it behind that microfacet thing, but it's bigger so you can sort of see it still. There you go. So that's pretty sweet. So we're saying this is the pixel that we're sampling. So we show array instead from the camera. And then you have, this would be interesting. I could do all the normals in this. I could do all the normals in this one, maybe. Yeah, potentially. No. That would just be a copy and paste of this diagram, but changed. So we say we do lighting from the camera. So we shoot our array from the camera instead and gather all that. No, sorry, and this, and we'll say that the microfacet, let's get to it. There we go. So we say we shoot array from the camera, and for this pixel, we don't sort of simulate the actual rough surface. We statistically, it is statistically handled with some maths and stuff, right? So I guess I don't need the normal in there because that's going to be in the next slide or the next diagram, right? So we shouldn't. Yeah, so we get rid of that normal and it'll be in the next one. So let's copy and paste this one because we want to keep the normal for the next one. So let's give a bit of a sort out the naming for some of this stuff. Right, so there's 5 diagrams. Round diagram 1. So, right, let's quickly remember what I was. So the colors that I want, I guess so. Yeah, so I guess we'll have the sun yellow. We'll have the sun. We'll have the camera. Camera is orange. Orange. Green pixel. And we'll have the lime color, which is now the sort of like, which would be the, it's not the view, it's the, it's probably the ray. Yes, the ray from camera. Camera ray, if you will. And then there will be till for the surface. And then from after this one, we probably won't do a roughness. May have a roughness thing like this, I don't think. Probably just make it not apply. So the surface with the pixel, camera ray. Maybe that camera ray should be a bit of a different color. I need to get rid of that surface. Yeah, surface normal, goodbye. So there needs to be an up. No, sorry, the color for that ray was just a bit not good. Guess I could do red. Or maybe a magenta, I don't know. See how it looks. Let's just do an orange. Camera ray orange. Yeah. So instead you shoot the ray from the camera. Yeah, ray from the camera. And that represents a pixel, fair play. Well, see, it's not really the pixel though, is it? Because the pixel will kind of be lit up there. Yeah, the kind of area the pixel takes is a bit in the world would be. I reckon it's good enough just for the diagram. Right, so the next diagram to do is to basically just show. So let's move up to the next one. So it is show the different vectors used in PBR. So yeah, all the different vectors. So I probably want to take this again. Let's just reuse that. So all the different vectors used in PBR, so that surface normal, That's still here. We then want to replace the camera array with a view. So the camera direction, or the view direction camera so red would be surface normal. You then want to direction towards the light as well. So light direction, I guess we just make that yellow. And then you probably also want well, I didn't even draw those. Whoopsie. This is the alright, ray. Hey Raf, how's it going? Welcome back, how you been? So pixel position to the sun. That one's red, this one's yellow. And then we've got another direction towards the... Wait, that's pixel towards the camera. Yes, that one's orange. So I think that's the vectors. Yeah, not doing bad, man. Not doing bad. Good to hear. Oh, I'm drawing them from the wrong place. Whoops. So from the pixel position. Then from... So they're obviously way too big. We just need to make them... That's just a unit length vector, so why didn't I just normalize it, you know? Shoot. Alright. Should be alright. Yeah, we're just drawing out some diagrams. Maybe it's a bit bigger actually. Just describing how PBR works. So we completed PBR very recently. So we're just basically wrapping up by doing like a little devlog, going over sort of like, you know, what PBR is, how it sort of works, and yeah, just visually showing lots of things about it. And the tools we built in the game, if you will. But yeah. We didn't talk about the environment map either. The environment map. Well, yeah, talk about the rest of the lights, like environment map. Stuff like that, basically. Alright, so 2. I think those vectors just need to be a bit bigger. So, bit, basically twice as big. that'll be legit. Right. Put that one. There we go. Yes, you have your normalized vector direction which goes towards the camera. Why is it pointing a bit off? Zoom. Right, let's test something out. So we have a sphere, and then let's say if it goes at position, where's pixel position? 0, 0, -6, right? So we say 0, +2, -6. That should go at the tip of the surface normal. So I want to see, like, you know, if anything, like, yeah. So I put it, what's that radius, right? It's like 0.25. What's I guess it's pointing in the right direction, is it? But yeah, so that's sitting on there now. Yeah, because we tested the vectors and we thought those were correct. I guess let's put one sphere on top of another sphere. So if we put that full 0.5 up, that should stack them, right? Is that a radius in world space? Radius, right? Did I mess up this? We just take max. Still a bit off, I reckon. But yeah, now is that already pointing in the right way? Maybe it is. Hey, Greenblade. How you doing? How have you been? Yeah, I think this is wrong. Probably just take max. I don't really reckon Min's gonna mess up in it. Megab's day work. Gotcha, man. Yeah. I just got home. Wow. Ooh. Hope everything's doing well though. Yeah, Min is not the answer either. For that translation, not gonna lie. I think it. Well, max is definitely better than lens, so I'm just going to go and do that. I got to change the GPU implementation as well. As GPU version. Max element. Right. Awesome. Yeah, so what are we doing? Let's get rid of those balls then. Right. So I did make those spheres a little bit smaller actually. So did we mess up some of the diagram? They're kind of a bit small. Let's make them a bit bigger. Make them 5. 0.5. Yeah, the diagram's got some spheres in here in it. There's a sphere, the sun. Alright. So that diagram should be finished, I reckon. So sun, light direction, surface normal, you got the surface, you got the view direction, and you got the camera. And then you got that pixel that we're trying to calculate, the sort of area it's going over. There's also a half vector. So we're missing one. And there's also a reflect vector as well. So what we need to do is we need to adjust the camera position. Let's bring it down by a little bit. Should we bring make the sun go up a little bit? We actually want to produce another one, which is called the... Oh, for crying out loud, I did the wrong one. This one. Up, down. So what we need to produce is what's known as the half vector. That's just the addition, the normalize of these two guys. So I guess let's just make some messy code. Well, I could just write them out. Let's put them into variables. So this one is the viewed. You have the light direction. Then you have the half direction, so the halfway between the two. That is simply adding and normalizing. View direction, light direction, noise. No, my code. All right. Yeah, let's just plop these in here. This one is the view direction. This one is what's known as the view direction, light direction. Do another one, half direction. That one can be green, which means we need to do another one of these boys. Wait, green, then that's same as pixel. Right, let's just do it for now. Could give it a different color in a sec. Yeah. I guess I can do like a violet or something. Why no overloading? Cause see, yeah. We do have generics, so I can do the G version. Capital G. C11 has generics. So they're kind of like, it's basically a switch statement, but with types. So you put in an expression, and it gets the type, and it finds the type in here, then it uses that one. But the problem is that the preprocessor will copy and paste this and put it in. So yeah, I could really use it, but I don't mind. I don't mind the suffixes. I think it makes the code more like you understand what it's doing, because when you just subtract, it could be like different types, right? So with this, you can tell the types of what they are, at least. So right, there's that half vector. Maybe I can bring the camera a bit more down. Put the sun a little bit more up. Whereas reading math, not the types. Well, yeah, that's why I typically like. Yeah, it depends, right? Like this is not a good example of a cleanly written code. This is just, yeah. But if you break it down into like individual lines and give things names, that can also be readable. Like, yeah, it all depends. It'll be still be hard to read. I don't know. It depends what you're used to, really. Like, when you read someone else's like maths code, what you find is it's all scrunched up, and they've given one letter names, and that is hard to read because you didn't write it and don't know what they are. But then I guess as you read it over and over again and figure out what the variables are, and maybe debug draw some of them or whatever you do, you start to it becomes more readable. So it really just depends on if you understand the context and if you're familiar with it as well. If you do a lot of math, you basically want to do a lot of math. No. I don't really do lots of maths, like in the institutionalized maths way. I'm trying to learn more of it, but I don't really do a lot of that. I come at it from a programming perspective where I want to know what my code turns into, so I can spot things, where performance could be bad or something like that, right? So, you know, like if you say, vector times scalar, this, if you didn't know your variables, what they were, that looks exactly the same. Whereas if you have them wrapped in a function, then you can figure out like, hey, the second parameter is a scalar, so it's just a, but yeah, so I kind of like having that information available. Yeah. You cannot let vec times vec. Why is that from a maths perspective? You can't multiply vectors. Is that what you're saying? Operating makes maths cleaner. There's no question. It's just not worth the cost of what means for a language to have it. So in the end, it's not a non-issue. Yeah. I don't know. Like if the language has vector maths stuff built in, I think that's okay. But yeah, operator overload in the language just makes stuff incredibly hard to read. But hey, Sofam, how's it going? I don't know. But yeah, this is cool. That's a good diagram. Half direction, view direction, camera, light, sun. Yeah. So I think maybe we want to move some of these in a little bit. Um, yeah, so that right side thing, maybe we can move that right side in a bit. Where is that right side? Alright, so if I cut that to the right by another 100. About 50 or something. Yeah, we need to move that in a bit more, 300. So the problems that like operator overloading causes is you don't know what that code actually expands out into. It's quite difficult sometimes. It's one of the problems with it. Right. That's in a nicer position. It could probably be a bit closer. But I forget what the other how big the other diagrams are. So should we look at the other diagrams quickly? So that's diagram 3. So we've done microfacets today. This one, which is the light, showing light comes from we do lighting from the camera instead of the sun. All different vectors used in PBR. Then we've got to do what is diffuse, specular normal distribution, shadowing for now. Right. So 4, I think, is this one, the diffuser radiance. Yeah, it's this guy. Right, this is still in a good place, so we can actually move it in a bit more still as well. This was the other one. Yeah, this is showing, hey, we've got this small texture array, which is like 32 by 32. It's this boy here. And for every one of these pixels, we are shooting a bunch of rays over a hemisphere and storing and then averaging the result, storing it back in the pixel, and it gets you the sort of thing. So whenever we get a reflected, whenever we get a surface normal, we take the surface normal, look it up in this smaller cube map, and then read the cached result. So that's cool. Yeah, that's a good one, but it means we can actually move this in a little bit more, so I'm going to say 400. Yeah, stuff is under the chat, that's cool. I am going to move it. I'm going to remove the chat when I record the video. It's fine. But yeah, that'll be alright for now. Oh, did you guys want to see it now? Apologies. So this box here is the irradiance map. That's the pixel. That's the normal vector, and all these are the sample vectors. Right, so back to the diagrams. The next one we want to do is what is diffuse. So we'll need a surface. I think we'll copy number 2. Let's go to 3. Yeah, actually, hang on a minute. Do we want to reuse 3? Four months work. Oh, you talking about the total number of days? Yeah, so you take the number of days and turn that into, working hours and that. It is about 4 months' time. So yeah, it's quite cool. We've actually done a ton of prototyping as well. It's not really been, half of the time, if you take a look at the VODs, half the time has been on, it's the hobby. So I work Tuesday, Thursday, Sunday, about 4 hours. But yeah, half the time is actually just me been messing around with ray tracing spheres. And then after a while, I I was just like, you know, let's just do some PBR and make the spheres actually look good, because I was just ray tracing a bunch of spheres and seeing how many I could ray trace and different ways of doing it, right? Doing BVHs, doing screen space tiles, doing frustum, Froxel, binning. So that's been from about day 50. Even anti-aliasing spheres. Yeah, so over half the time has been ray tracing spheres. The rest of the thing, which includes UI rendering, was all done at the start. Input as well. We got gamepad support on Windows and Linux. So yeah. Um yeah, it's been quite good progress. Quite good. Um what do you mean by input switching? Do you mean like, I don't know. But yeah, the game can recognize like any USB that you plug in. It will be like, oh, you've plugged in a USB device, and you'll be like, and you can sort of, it could take like the vendor number and the device number and use that for something if it wanted to. But we only pick up on like game controllers at the moment. But yeah, I thought that could be something fun where you plug in like a random USB, take the numbers from it, and put that in the game somehow. So, There's some modern games you can play using the keyboard or controller, and it always switches between either one of them. Yeah, I don't have a higher level input system. I only have the low level input system. That still needs to be worked on. Um, but yeah, it's not hard. I've also got multiple keyboard support. So you can have multiple keyboards, multiple mice. You can plug them in and they get picked up as different devices for some reason. Hopefully I get to use that. Support. Let's go. Oh yeah, keyboard support. Yeah, that'd be easy. That's not too hard, is it? What do I think about OpenGL, DirectX, or Vulkan versus? Well, OpenGL is probably here to stay because it's the easiest one to do, and Vulkan and DirectX 12 are just, they're more designed for engine programmers because they're very involved. But they allow you to do some awesome stuff because they're new. Um, and you can get stuff like the new features which are in Vulkan and DirectX are really great, but it's still not um, yeah, it's still not all the way there. Um, they have to support like low-end devices, mobile hardware, which has, so it's still an abstraction over GPUs, unfortunately. Unless you read into the the instruction set architectures or the hardware documentation, you still don't really understand what the hardware does if you just use Vulkan or DirectX. But you can see how they would kind of map when you understand the hardware underneath. But yeah, it would just be nice if we can get more access to the hardware and how it works, and yeah, get rid of some of these complicated layers because they're really complicated. And GPUs have pointers, so give us pointers and shaders, please. There's probably reasons why they didn't do it. What can you do in Vulkan? Um, Basically, like you can manage memory where you can you can basically have you can alias you can have resources which overlap. Um, so you can create stuff like these things called temporary resources. So they have a very small lifetime over. So you could say at the start of a frame, I'm using what's it? Drawing time. There's a whole bunch of features, but this is one of them. So you have a block of memory, and you could say at the start of the frame, so you got this texture here, and this texture maps to here. This texture maps to here. You've got this other, and maybe this is only used for like literally right at the start of the frame, and then it does, and then it's not used anymore. And then there's this texture which is used later on in the frame, and this one ends up just using the same place in memory. You can basically have overlapping textures, or maybe that one goes there and another one uses this portion here. So you can essentially have temporary, you can have very short lifetime resources. But if you use them at the same time, they are going to, overwrite each other's memory and it'd be horrible. But so you got stuff like that. You've got this thing called bindless resources. So with the bindless resources, you can basically pass around indices to textures. So in our shaders, all of our resources are basically just integers. So I've got this draw 3D buffer. So these are some constants. So we might go making them constants at some point. But yeah, you can then just cast a constant. This is our custom shading language. It's basically just C for shaders. Yeah, it's basically C. It's a C shader compiler with some extensions. But yeah, this is just a 32-bit integer, but behind the scenes it just indexes, grabs the buffer from the bindless buffers in the shader, and then you can just start using it. So we can just pass in all of our shaders, all of our resources, just as 32-bit integers from CPU side. So you don't have to bind them into specific slots, they're just data, you can pass them around. But you have to do the synchronization code manually. If not, you will get wrecked. Yeah, you have control over memory and some, but it is in a very archaic way, though, which is a shame. But you can still do it. There's bindless resources. There's also you record stuff into a command buffer, and people will be like, "Oh, it's a hardware command buffer." I've heard that when you do a submit, it translates that hardware command buffer into into a different command buffer specifically for that card in the driver. So I don't think it is a actual hard. Anyway, you can call stuff into a command buffer and then submit it. So, and you can control when things are actually submitted to the GPU. Whereas in OpenGL, you don't really know when stuff is actually submitted to the GPU. I know there's that GL finish and stuff like that, but it could technically do it when you do a draw call. It could just flush it all out. Does OpenGL have command buffers? Did they add those? Right. So what's the next thing to do? So I want to say what is diffuse, isn't it? Oh crap, where's my things? There we go. What is diffuse? So line from the camera. Yeah. So what is diffuse light? So Yeah. Um, hmm. Yeah, I might get rid of that. Oh, no, no. Should we keep this diagram? Yeah, so say we diffuse and say it bounces around in here and then comes back out. We'll say that's the camera. Um, right, let's make the camera bigger. Let's try that out. Oh, as an extension. OpenGL like Vulkan. No way. Oh. Command list. NV command lists. Great. Great. Right, this is emulating it. That's the difference. Different. Full command list then. But yeah, I don't know, maybe they've added it as some extension, but still not OpenGL. Yeah, if it's an extension, it's still not OpenGL. Give way to manually manage graphics memory, and I'll be sure to make that memory leak. Guess. I don't know why. I don't know why you'd have that problem because resources on graphics, when you do graphics, are typically like, you know about them. Like, hey, this one is the texture that we draw to. You're not really doing them dynamically too much. And if you get memory leak, you'll know because you know a few frames later you run out of memory and boom. So um, right, so they're a bit bigger now. So we're doing diffuse. So what's diffuse? So should we bring back all the rays? Um, so really, you need that sun. So you need that sun, and really, what you're saying is when rays are shot, from the sun, they sort of bounce around inside the surface, and when rays are shot from the sun, they bounce around in the surface and then shoot back out towards the camera, essentially. But yeah, again, that's all statistically done. It's not really, you don't really trace rays inside here. But we should probably show it in some form of diagram. See, I don't know why I didn't just make a little tool which allows me to click, 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 and it just draws a path with rays. Because that would just, and then it just outputs the list into the terminal, and I can just grab it and put it in the code. That is but then I'd have to do it on a plane. Possible though. Oh yeah, but it's all in world space. Yeah, bring in screen space, so because then I can just go boom, 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 and just yeah. That would be the way. And then you could do the problem is though is if you increase that roughness, it would work. But yeah, I think what we'll do is we'll just hard code it because it will take probably a similar amount of time. So yeah, I don't want that ray anymore. But you probably want a couple of paths, probably from the camera. Sorry, from the sun. You'll go sort of near that pixel that we're sampling. I don't really know if I want that pixel to be shown anymore, not gonna lie. It's alright, sturdy pose. You'll yeah, just keep going at it, you'll pick it up. Right, so we want so I think we can just build it. We can just say ray and we'll just build a path. We'll just build a path. We'll build a couple of different paths. So we'll just say previous ray, and we'll just keep. Yeah, we'll just build a few different paths. So we'll go to the floor, go in 1, 2, 3, and 4. So we need 4 segments in each path. So we have path 0. Have 4 of them. So it'll be something like path 0. So this is going to go to let's figure this one out. So this is going to the center of that pixel, I guess, which we'll probably delete. So that'll be -0 -5, right? From the sun. Sure. Not doing that anymore. Okay, so we're gonna throw the previous ray in there. That's the first segment. Wait. The problem is you have to. Right. It always starts at some position. What am I doing? And the next one is going to be something like, so move it a little bit down. So I guess we'll go like, so it's going to hit the surface and then we didn't talk about refracting, but we haven't really implemented any refracting anyway. But yeah, it will like refract in. Yeah, so you get sort of refraction. So you'll hit and sort of bend down a little bit. So Yeah, so we probably want to say it goes down by maybe 2, I guess, and then it will go to the right by about right 3 and then 2. And then you probably want to make it bounce a couple more times. So let's go over to the left somewhere. Yeah, let's just bring it to the left to -2 or whatever. And then the final one goes out to the it'll go out towards the camera. So we'll just say camera pause. So it goes out of bounds. Right. So that's our first path. Let's just get that going. So we just go over our path 0 to 5, and then you want to draw a vector, right? So you basically get that. You calculate. So you always go previous start. Yes, you always start from right, and you have your previous ray, previous position, and so that previous position is equal to path 0 of that, and then you basically just want to update that. Then you get your vector. Vector would then be sub. So going towards this one from the previous one, and then essentially that the vector we're drawing in space is going to be starting at previous position and with that vector there. So let's take a look at that path that we just drew and see how crazy that is. Right, that clearly failed. So the problem is this surface is, yeah, we can't see through the surface. So what we have to do as a compromise is give it a border so we can see through it. Why didn't that work? Oh, 2 is way too big, maybe. What about a 1? Oh, thank you, Ink. Ink Ferez. Thank you. That is definitely a problem. Right, yes, we're seeing it come out the floor now into the camera, which is cool. That's obviously going a bit too far, though. We'll probably need to move that back out a bit, but why do I see... Oh. There we go. Right, so this is diffuse, right? It goes into the, yeah, bounces around a bit and comes out. So it will get the color of the surface. So, yes, here's our lovely surface. Goes in, bounces around. So I guess you could show it like absorbing more and more of the color, but there's that. Yeah, we should probably move this down a bit and give it a bit more. Maybe the sizing can drop down a bit as well, since there's going to be a few of these. Yes, that one could be dropped down by... yeah. Sweet. Right, let's re-center that. bit obstructed there. I guess it's not proper refraction. That should go down a bit, but a little bit thicker too. We'll move this, I guess, down a bit more. Um, hmm. I think we should change this up a bit. This. Let's make that a bit smaller. We go back to making that path a little bit bigger. Hey Rizima, welcome back. How you been? Right. So I'll refract, bounce around, and go back into the camera. Yeah, I guess so. And then we can go over and talk about. Right, let's change these colors. This is wrong as well. That is probably going a bit too. So where's the camera position? Let's just grab it and. So we bring it back by 1 and 1. Let's try that. Bit too much, so we'll 0.5 it. Been a while. I see some corners, more corners. Yeah. So we're just working on some diagrams to describe how this PBR works. But yeah, so we've done PBR. I've added that into the engine, or the game rather, into the renderer. So we can now make sort of like rougher surfaces basically, and plasticky and metal looking things. We've got multiple lights here showing up as well. We also have some debug views where we can view like individual aspects of the PBR shader and see how they behave when we tweak values. So yeah, this really makes things look better. I'm not sure if we want to go for realism, but people typically do PBR in non-realistic rendering art styles anyway these days, because just having like a more, like the current trend is having more realistic light, like believable lighting, but not necessarily having realistic materials or art styles. So I think they kind of like, yeah, that's the kind of trend at the moment. That's what makes things sort of look nicer and feel more visually appealing, is just having more physically correct light. So yeah, we definitely got to tweak around with shading and more in the future, but for now, just chucking this in just makes things far better. Oh. Yeah, so I guess let's just get some of the colors, excuse me, and the labeling better. Yeah, so we'll just say diffuse is, essentially it's simulating light coming from. All right, let's get these right. Not. Do we want the normal vector? I guess we can have the normal vector. It doesn't hurt. Where's the sun? It might be some kind of uncanny valley some kind of uncanny valley avoidance trick trend. Anyways, looks fancy. I don't know. Yeah, because you don't want stuff to look like. See, there's just something about it. If you have very terrible graphics, but you have like insanely good lighting, it kind of makes up for the terrible graphics. Obviously, your graphics, should get better, but like for instance, just take Minecraft and just put really good lighting in there. It mostly look, even though it's just bricks, kind of makes it look way better. So I think it's just generally lighting just makes stuff really look good. Thank you, Timo. Appreciate it, sir. Yeah, we're probably going to work on like one more rendering thing, and then can actually probably move into working on some editor, which allows us to make objects out of spheres and whatever. Because I want to be able to populate the game world with proper objects and kind of bring the game into existence. Because right now we've just been like, messing around with spheres for a while, and I think I've kind of settled on what I would like the renderer to kind of turn into. So yeah, I think we're going to delete. We'll rename this file all the GFX stuff, which is all of the implementation of all the 3D graphics, which is not including the Vulkan abstraction layer. That's separate. That's GPU. GFX is the layer on top. So we'll probably like rename this, keep it for, as a thing to refer to, but we'll just sort of take all the good bits out and have a nice fresh restart. So it's gonna be good. So the sun in the light direction. Or light. Actually, we've actually got light. Yeah, so got a bit of sun, got a bit of light, got a normal vector as well. So just keep that in there. Got the pixel, the same the irradiance map. Sample vectors goes away. Oh, but we need a camera. We'll do it. So that's orange. Camera. And then we want, this is the surface. So, yeah. Sweet. Surface, pixel, camera, normal vector, light. That's technically like a lime, to be honest. Right, so I think we can describe what diffuse light is from there. With enough. Right, it bounces around, but there'll be multiple rays, right, doing this. They bounce around differently. I could maybe do another ray, right, but I don't know how confusing that will get. We could do one more. Maybe, but I think it would just be too much. Maybe I can put it there, then there. Right. Let's try it out. It's got to be enough. Yeah, let's do a slightly other one. Well, okay, it could actually just be, yeah. So I'm thinking like, so that's where it's going to hit. We can make it hit just like a little bit to the left. So just say -1. Then we obviously want to make it move probably to the left and a bit up. So -2, probably 1. Then this one is going to go to the left of that and probably a bit down. And then just go right up to the camera. So that one, I guess, it's another one. So previous position. All right. Give that a go. Maybe we can give it a bit of a different color. But, right, clearly too much. Oh, I do not know what's going on there. Let's disable the original one. And let's just take a little look. That's what the crap is going on. So it went to the right there. Whoops. I meant to go down. Right, and then it's just going like that. Ugh. Gross. So let's take a look at that path. Oh, okay. So really I want it to just be 3. And then when we talk about going to the left, really want to go a bit more to the left. And let's try that out. Trying to read something about PBR, my knowledge stopped at Blindthong, that stuff. Oh, okay. Yeah, you got a bit. Alright, let's keep that more at the same level. Yeah, there's a lot of good resources out there. I can link you to some. There is. Let's go onto my Discord. I've got one on there. So there's a shader toy. So if you're on shader toy, you can play with a shader. This is what we played with. Yeah, I didn't kind of use the implementation, but there's a really nice shader you can play around with. Highly recommend this one. Like it's interactive and it's awesome. There's some great videos which break down the maths side of things, which I'm not going to be doing because I'm probably going to talk about the code though, more generally, because that is helpful. There's this one here. So it talks about like how light works in real life and how everything is, how we simulate light in games and such. Yeah. And then yeah, it doesn't go too hard into the maths also, you know. This is a good blog post as well. And then also you obviously got the Learn OpenGL resources as well. Learn OpenGL, PBR theory. They also do image-based line, which you need if you want to make your metals look good, because your metals don't do diffuse light. They only they don't reflect diffuse light. They don't reflect diffuse light. They only reflect specular. So maybe we should do a thing where we don't draw the rest of the path if metal is basically. So when we drag up the metalness, we're like, oh, when your things are metal. So I can't make these transparent, or can I? No, we don't do blending in the shader. But yes, the rays come down. They'll reflect around in here. That one should come down a bit. Yes, the rays come down from like a light source. They hit the surface, they refract, bounce around, and then they so happen to actually go back into the camera in that direction. But yeah, obviously I'll describe that, you know, this is how it happens, how it basically happens in real life, but this is all just, this is not simulated, you know, yeah. Then I probably want to go and show the diffuse part. Oh yeah, I want to do the metal thing. Then I want to show the diffuse part here, where you show diffuse, and it's showing the light, how it looks, and then you increase the metal and you watch it just fade out. That's the diffuse part of the PBR. So there is a metalness thing, right? So the rest of the path, we could say, see, making them disappear one by one is not good, because the ray would never get to the camera then. But yeah, you don't really have objects which are half metal. So what we'll do is we'll just say, right, if material dot metalness, if that is greater than 0.9 or less than 0.9, we'll display 5. If not, we'll just do the 1. And we'll do that. Oh. Right, so that'll just show that, hey, there's only, but as your surface becomes metal, where's the raise? It's exclusive loop in it. Audio. Yeah, so as your thing becomes metal, the diffuse doesn't contribute to the lighting at all. The next one is specular. So that's that diagram done. We're going to copy paste it and do specular. I guess we can also do a bit of roughness as well. We could probably have the roughness parameter movable as well. It says repeat 3, make it a 4, and then move the old 4 to 5, the old 5 to 6, and the yeah. So let's go to 4. So with this one, we just want to do a reflect, and I guess we just do a few of them. So I think we could just put a couple of positions in. So I want position. So you have the hit pauses. So hit pause 0. Hit pause. So -1, 0, 1. So we have 3 positions. And I think what I would like to do is wait. Maybe what we'll do is just have one hit position, and we will just spawn 3 vectors towards the camera, which, what are they going to do? They probably will just break apart as you increase the roughness. No, you want 3 separate rays. So you get the reflect ray. You think the problem with the video is that pre or microfacets are? No. Oh, why did I keep doing that activity thing? Oh shoot, what have I done? Because a CG perspective in real life, it would be obvious. Yeah, I think he describes that in the video though, right? He's saying that an object isn't perfectly flat. It's like he actually goes into it in insane detail to the point where he says that the light, if we just find it, he says that he goes into it in such a big detail. He talks about like light, what light is, you know. That's all like this is all scientific. And talks about how it hits atoms and how how the atoms respond and everything, and how the light bounces off them and that. And then talks about here nanogeometry, right? How there's no perfectly flat or smooth surface, right? And then from there, yeah, he talks about like how there's this thing called diffraction, which we don't handle at the moment in PBR. And then he talks about the end how it does actually contribute in tiny places, so they should look into figuring that out. And then basically the microfacet is essentially just a way of it's bigger than nano, right? But yeah, it's just basically saying the thing isn't flat. It has some degree of yeah. Yeah, that's correct. No. Isn't the concept similar to porosity? Or is it smaller scale? I've never heard of porosity. I'm not sure what that is. Yeah, with specular, do I just want to just show... Yeah, I guess I'll just have different hit positions. They will reflect. They will reflect and... I won't necessarily have to put them into the camera, will I? Hmm. Hmm. Yeah, we can just show them breaking apart differently or something. I don't know. Yeah, I think what we'll do is we'll just say... Yeah, we'll make them just a little bit like that. You'll go over all your different hits. And what you'll simply do is go from the hit position to... I just got to get the number right. That one. To this, which is basically the camera just a little bit earlier. Wait, no, we're not doing that. I think we're going to do a bit of a reflect actually, aren't we? So we're going to produce that reflect. So reflect based on the surface normal. That's just directly up. Yeah, it's not necessarily simulation. Yeah, it's more statistically. Yeah, that's correct. But yeah, it is kind of a lot to take in. Like, I understand it, like PBR now, but if I try to explain it, man, I have to start thinking again. But yeah, it is kind of like it's possible for someone to understand it though. It just takes a bit of time for it to sink in. You have to have a bit of a play around with it. But it is relatively simple once you understand it. Oh yeah, there's that PBR book as well, isn't it? The crying out loud, I've got this damn activity thing that keeps showing up. I've pressed a special key. Console activity in session. I've pressed something dumb. I've intentionally pressed. Right. I think I pressed Control Shift A, so I think that should have fixed it. If not, it's in the menu somewhere. Anyway. Yeah, so you do the reflect. Now, I think we say based on roughness, we'll just move them a bit along the X. So I think we could just say vec.x plus equals. Then we'll cast this into like a float. And then we'll say -1. So that'd be -1 or 0. Or I could just say index equal not equal 0, and then so then turn that into times by 2, take 1. That'll get us -1 to 1. And then from here we can just multiply that by roughness. So that should be something to play about with. So when you've reflected that, let's try that out. Okay, that kind of went a bit weird. Cool. Oh, we never moved the things to like a -6. Hang on a minute. Still a -5. Even pixel position. Right, we must go back to that previous diagram, just check it. Right, let's go back to that previous diagram. Diagram 3. Right, that looks fine. Cool, let's go back to diagram 4. So yeah, so what's going on there? So you're reflecting, right, hit position. So it's using a position and not a vector. So we need to go towards that from the sun. So I think that roughness should help. Yeah, there you go. So I'm not drawing both vectors. That's the roughness, right? It's going to cause it to move a bit. We'll probably multiply it by something bigger. 3. So we actually need to draw the other vector as well. So we'll call the first one vec and no vec1 0 1, you know. So from sun to vec 0, sorry, sun with vec 0 and then hit position with vec 1. So vec 1 gets the adjustment based on the based on the roughness. There we go. Cool, so I think we want a different color for that reflected ray as well. But here we're just saying that specular is basically, it's along the surface, right? The rays come down from the light source, they hit the surface and reflect back out. And obviously the ones that can't quite hit the camera, they're the, yeah, something that I need to be incredibly clear about when I talk about this is that these rays from the light source, when you have a ray that comes from the camera and you're gathering a pixel, I guess this is what this pixel is here, right? You're not looking at all the rays that possibly hit that pixel and bounce into you. You're kind of like, you're working out statistically with like a percentage, but basically how many of them are coming from the light and reflecting into the pixel you're coming from. Yeah. Yeah, I think that diagram's good enough. We could go back to making that like a proper box, to be honest. Because we only needed it for the diffuse to say that it goes inside, but then with the yeah, it's going along the surface like that. Cool. So we probably want a different reflected color. So that's an orange we've done before. So light reflected light. Light reflected light. Normal vector camera pixel surface. Do we have the normal anymore? Brought area lights to unity. Fair play. Yeah, I've not really understood the complexity of area lights. But yeah, thank you, Speaker Breed. I need to figure that out. Like what the complexities of an area light versus the other ones. Neat. Very concise. It's proper compatible article with the Gen Z lot, you know. TLDR. Right, so it's reflected light. Yeah, we don't have a normal vector in here. I think. No. I think we did. But yeah, so it's like an orange. An orange. Yeah. Normal vector camera. What's big enough? So there's the reflected light. Noise. Right, so that describes those ones. You know, I guess I could just have like a button to switch between them rather than keep changing something. So I have it as a static. So static diagram index and we'll say if OS virtual keyboard, if the key code has been pressed for the key code of left, then we will show a negate. And then if we say go to the right, we are then going to, yeah, I don't know. I don't know what the max is, to be honest. Not sure if I will. Well, I do know what they are. They're all written out here. So I need a max of 1, 2, 3, 6, 9, 10. Right, so now we've got a way just to, you know, switch through these diagrams, easy peasy. Well, at light speed. So not is pressed, has been pressed, this frame. They're obeying because you need to integrate over the area of the light, which you don't have to do for point or spot since the light comes from one point or direction. Case. They basically come from anywhere in a single direction. Wow. And yeah, the link is just a TLDR. There's a paper available there. Also, WebGL demo. Nice. Pretty cool. See, a lot of this rendering stuff is just hidden away. And Googling for it, I find, is a lot harder. Like, if you want to get into, like, network programming, you've got the keyword netcode. I don't know what that keyword is for graphics programming. I feel like there's just tons of them and you have to sort of know. Or the right people to follow as well. Yeah. They're coming around alright. They're good enough. Right. We're nearly there. So we've got to talk about, that's the specular, what specular is. We've got 3 more diagrams. We've got normal distribution. That's going to show the specular highlight, like how many rays shoot perfectly. Statistically, how many rays? Yeah. Reflect perfectly, isn't it, basically? And it gives you that sort of nice dot. Hey, collector of stuff, how's it going? How you been? I think that's the way what it is, right? Normal distribution. Let's read the code. That's my, is that the GGX? Yeah. So if you go over to the lovely spheres, it's this. It's the normal distribution. Bing. That little bit there, but you also get more. There's how many of those. So it gives you a percentage on how many of the microfacets are. Yeah, I guess perfectly reflect into from the light to the camera. Basically. N.H. Yeah, something like that. So refresh to see a new immediate mode GUI. It's not stock and GUI. Intermediate. Do you mean immediate or intermediate? You mean immediate mode UI, right? Yeah, we got our own little texture view as well, so it shows off a lot more. We'll ignore this. Move it the way. Just it's in 3D space. Woo! This is yeah. So we can take screenshot. That's a screenshot of a screenshot. Also view some textures as well. A little fuzzy search thing for when I need it, right? Yeah, you can like view textures, view their MIPS, and zoom in. Change the black white levels. That's the linear color in it, so yeah, what else can you do? Where's the logo? Oh, MIP 3. There's a bug. No. Doesn't reset the number of MIPs when you change the texture. Yeah. Pretty cool. Let's fix that bug. GPU. So when you select a texture, res ID equal whatever, right? Tab res ID. Yeah. Select command. No. MIP 0. Array layer 0. Alright. I think that's alright. I'll fix it. Yeah, so normal distribution function is showing how many of the rays perfectly reflect into the camera, and it will use the normal dot half vector in it. So you need another one. So it's it was now as 4, wasn't it? Give samples to discover keywords and those advanced rendering things. It's probably the PBR book available for free. Real-time rendering also. Recently, I have there's been lots of those good. Thank God, lots of those have got released. Oh yeah, the ray tracing gems as well. Yeah. Ah. Yeah, so it's not any more of that KDE zoom, which is linear blended. It's horrible. Except for the cursor. It's strange. Yeah, so it's copy paste 4. So normal distribution. So it's basically just saying it's how much of the light reflects directly. So I guess we could do a bit of a combined version where so I think it's a ratio, right? So you got alpha is between 0 and 1. Dot is between 0 and 1. Then multiplied by so so this gets maxed between 0 and 1 then. Divided by so it's all between 0 and 1. It's a nice little ratio in it. So I can remember that. So you're saying how? So I guess we can combine the two of them, the specular and the we can nick one of the paths. Somewhere here. Nice. Right, so we go to the next one. Okay, so it actually needs to have that floor taken apart. What do we do again? Is that 0.1? I think so. Oh. 0.05. Oh yeah, next one. Cool, so this is saying, so what we would like to do is say, so with a normal distribution function, it's giving you a yeah, I guess giving you a ratio of how much, so the ray coming from the camera, a percentage of how much, or ratio of how much of the light is actually hitting is wait, no, normal distribution. Why did I put the diffuse in there as well? That is so dumb. Why did I do that? So get that path out of here. That's a bad idea. Yeah. So with normal distribution, we're going to say given how many of them are perfectly hitting, perfectly reflecting. Shoot, what did I do? Oh. Am I just keeping the same diagram then at this point? How many of them are that perfect reflection? Yeah, we should have a bit of a different diagram to describe it better. But yeah, so normal distribution is how many of those perfectly reflect yeah, how many of the rays are perfectly reflecting into the camera or something like this? Then you got the geometry shadowing, and then you got the Fresnel as well. So I know how to do those ones. It's just this normal distribution. So we show a perfect reflection, and then see, in this case, it'd be very white, right? Here's us. Let's go and take a look, right? So you can see the light source in here. That's the normal distribution, right? So for oh yeah. We need the half vector, right? So we should probably show the half vector in there because we're going to be talking about how you calculate it. So I think we need the view, the light, surface normal, and the half direction. We should put all those in there. And then we should say, I guess I got the previous diagram. Yep. The balls. Zoom. Yeah, so maybe we should bring those. There's that half thing that we did. So if you'd so let's just bring all these in and plop them in here. Let's see how they actually look. Right, so we probably want to move around the actual. So the sun can come up, maybe the camera goes down. And that's kind of what you get for the Fresnel in it. Yeah, let's just do that. I think we always want it to be like that. But what about all these? I don't ever want to draw these paths anymore. Or these rays anymore. So maybe we might do though, right? So right, the other one should go. Yeah, that's a bit too big. So yeah, there's our half vector. Maybe we will draw them bigger. So when it comes to the normal distribution, it's based on the dot product between these two, and basically the closer they are together, the more of the specular highlight's going to show up. Yeah, I want to say in this diagram form, you're saying you're statistically saying the rays that come from the light, how many of them, or do they bounce? Yeah, I guess, because yeah. Because if you go to the normal distribution, right, notice how, like, even if we turn the light intensity down, if you whack up that roughness, it just, you know, yeah. So we could just say it's a percentage of how many of the rays from the light are that perfectly reflect into the camera. That'd be a way of saying it. The rougher it is, the more. So maybe I think I can draw a ray. We could probably draw a few rays, and they'll perfectly reflect. And as you increase the roughness, As you increase the roughness, they go apart. Right, but they're all going to go into the camera this time. So they should always go, they shouldn't reflect. Instead, it should be going from the hip position towards the camera. Well, not really directly towards the camera. There was a sort of a quicker, sorry, a constant version which was just a little bit before the camera. So I think we can draw these. We kind of have a lot of vectors here, but I think we can solve that problem. Oh, the camera's in a different place now. Yeah, I think. Oh, with the roughness, we wanted to probably move the do we want that pixel sample location? I guess maybe. Yeah, which one did I want to move? I want to move the hip pose on it. P. Yeah, so we move that roughness. Oh no, it's the wrong one. Right, first of all, let's start off at 5. Second of all, remove P. Ah, there we go. Sweet. So we move roughness now. There we go. Yeah, so I think we can just say, so when obviously it's not very rough, you're just going to get the rays around here. But then the part of me just wants to draw many of them spaced out. Yeah, I think we can do something like, we can just say, hey, we want 8 rays. And I think we'll just do a for loop. We'll initialize all those. And what I would like to do is say, based on how rough it is, so I guess we can do index take index take 4, which is halfway. Or 3 would it be? That'd be 4, wouldn't it? Yeah. You're 9, so there's, yeah, so you take 4. And then you can scale that based on material roughness. So that then gets you your hip positions. And I think that'll be a good way of representing this normal distribution. Yeah, so it's, you're saying how many of the rays point towards, that might be, this maybe is a good way of saying it. I don't know yet. Alright, I'm gonna sleep. Nice one, Green Blade. It's fun watching a stream. Hopefully I can catch the next one. Awesome. Yeah, I'll see you in the next one, man. Have a good start to your weekend. I'll see you on Sunday, hopefully. Yes, you're saying statistically, how many of the rays reflect into that sample areas reflect into the camera? Yeah. The problem is, see, I want to put. Okay. We should move that pixel position in front. Where's that pixel? Way in front. Okay. Just so that's. Yeah. The problem. Problem is that isn't the perfect sort of. Well, that is probably the perfect reflection, or it was at least. Um. Yeah. When does this become? Yeah, exactly. This is the problem I'm trying to fight with, isn't it? Like, it needs to look better so people can understand what this is doing and what I'm saying at the same time. But also, yeah. See, I'm not sure about this split thing anymore because there's a location that you're sampling at. Hmm. Hmm. Yeah, I'm not sure about this one. I need to think about it. It's a good first step though. So there's only actually a few more diagrams left to do, and then we can just record the video. So I'm hoping I might get some time off stream just to finish off the diagrams. So next stream we can just focus on just doing the video, and then just moving on from this. So yeah, next stream we're just going to record the devlog basically. So we'll execute this plan. And then probably, like, put it this way, we're probably gonna get this all recorded and there'll be some time left over. So we'll probably do the engine refactor after that. Just begin that engine refactor work, and start the clean up this file basically, and probably refactor the engine just a little bit. Right, let's find somebody to raid. So that'll be on Sunday at probably 6 p.m. GMT +1. Yeah. Right. Man, I'm so tired. Do. Amadeus is kanji. We now see what kanji looks like. I've not seen kanji before. Kanji. I'm just gonna rate Kanji. I haven't seen him for a while. I hope he shows what his code. I'll see if I can get him to show what his coding. We'll see. Anyways, have a good good weekend, end of your week, and I'll see you all on Sunday. Thank you for coming by. Catch you later.